Okay, guys, this last, thank heavens, right? The last miscellaneous equations is just kind of a combo of everything, okay? Nothing really new, just, like I said, a combo of everything. So in this case, you're going to have to recognize it, if you can, as a different, or as a quadratic like. Do you see how this is h to the first, this is h to the 1/2. If you take h to the 1/2 and square it, you multiply the exponent, so that's h to the first. When you have that, you have something that's like a quadratic. So I would want to move my 2h to the 1/2 over by subtracting, okay? And then get it equal to 0. And now it's something like a quadratic. Instead of having h and h here that I'm trying to factor, I have h to the 1/2 and h to the 1/2, right? If I multiply those together, I get h. What multiplies to 1 is 1 times 1. It looks like I need them both to be subtraction. So the answer to this is wherever h to the 1/2 minus 1 equals 0, which would mean h to the 1/2 would equal 1. I would then square both sides and get h equals 1. Now I would definitely check this, you guys. Sometimes there's no solution. Since I was squaring and square rooting, there's a square root here and I'm squaring, etc. I might have, maybe this actually doesn't work once I put it back into the original equation. But when I put 1 in, I get 1 plus 1 is 2. 1 to the 1/2 is 1. 2 times 1 is 2. So yes, that was the correct answer. Now for this one, some of you might be thinking, well, isn't that just a square root problem? You're right. Remember, math is like pasta. Lots of ways to solve them. I could have divided by 2. Okay, realizing h to the 1/2 is the square root of h, right? And then just kind of squared both sides right away. But that's kind of yucky to do, but that's okay. We'll get h squared plus 2h plus 1 all over 4 equals h. Let's multiply both sides by 4. h squared plus 2h plus 1 equals 4h. Subtract the 4h from the 2h. I can factor that, right? h minus 1 times h minus 1 equals 0. It looks like I get h equals 1, which is what I got the last time. If you didn't recognize that it was, a quadratic like, you still get h equals 1. All right? So either way. This one, definitely we can recognize as quadratic like, okay? 1/4 squared is 1/4 times 2, or 2/4, which is h to the 1/2. So I have x to the 1/4, x to the 1/4. I'm thinking what multiplies to 2 and adds to 3. That would be 2 times 1. So x to the 1/4 equals 1, or x to the 1/4 equals 2. To get rid of x to the 1/4, or to get that to be just x, I raise it to the 4th power. 1 to the 4th power is 1. Raise both sides to the 4th power. X is 16. Now you would want to check those. If I put 1 in here, I get 1 minus 3 plus 2. Does that equal 0? Yep. If I put 16 in, square root of 16, or 16 to the 1/2 is 4, minus 16 to the 1/4 is 2. 3 times 2 is 6, so I have 4 minus 6 plus 2. Yeah, actually, they both work. Okay? Let's go back to absolute value. All right, absolute value. When I have absolute value equal to something, that means what's inside the absolute value either equals what it says it does, or the inside of the absolute value could equal -1, because in the end, I'm taking the absolute value of it to get 1. So I'll add 1 to both sides. take the square root. When I take the square root, I have to say plus or minus. Add 1 to both sides. Okay, so I'm checking these out. If I put 0 in, 0 minus 1 is -1, absolute value -1. Yep. If I put square root of 2 in, square root of 2 squared is 2. 2 minus 1 is 1. Absolute value, that's 1. Yep. And of course, negative square root of 2 squared would be 2 as well. Okay, so all those worked. Same thing here. What's in the absolute value either equals z, or what's in the absolute value might equal the opposite of z. So I have z squared minus z minus 12 equals 0. Z squared plus z minus 12 equals 0. I have two quadratics to solve. Multiplying to -12 and adding to -1 would be -4 and 3. So I get z to be -4, or z is -3. This one, oh, it's kind of the opposite, right? I'm multiplying to -12, but this time I want a +1. So I want z plus 4, z minus 3. So z is going to be -4 or 3. Okay. Oh, hey, thanks for telling me I made a mistake. I know you were. I couldn't hear you through the time, time travel. So we add 4. Yeah, geez Louise. Z's 4. Z's -3. Z's -4. Z's +3. Okay? So let's see. Either whether I have 4 or -4. When I square it, I get 16. 16 minus 12. Oh, wait, this does make a difference, doesn't it? Sugars. I can only equal a positive number. Okay, so when z's -4, I'm saying that the absolute value of 4 is -4. That's not going to work. When z's -3, I'm setting it equal to -3. I'm saying I'm taking the absolute value of something and getting a negative. The only two that actually work are 4 or 3. Okay. If I put 3 in here, 3 squared is 9. 9 minus 12 is -3. Absolute value -3, yes, that's 3, not -3. Okay. And again, where you have to be careful and double check. Here I have that what's inside the absolute value either equals 1, or what's inside the absolute value equals -1. Hopefully you pause me in order to write the equation down. You're probably getting good at pausing me. Okay, so I'm subtracting 1 from -2. I'm adding 1 to -2. Okay, just to get equal to 0. Okay, so I subtracted 1 from -2. I added 1 to -2. I'm going to hope these factor, but if they don't, I'll have to use the quadratic formula. Let's see, that's 2x squared. I have a 2 and a 3, so I'd like the 3 to be negative to give me the -1 in here. So it looks like 2x minus 3 is 0, or x plus 1 is 0. X is -1. X is 1.5. So far. I'll check. Don't worry. Oh, I just don't know. Is this going to work? 1 and 1 is all I have. It's only, these are my only options. So 2x squared. I have a 2 and a 1. Yeah, if I get my 2 negative, my 1 positive, that'd be minus 2x plus 1x, which would give me the minus 1x in the middle. So 2x plus 1 is 0, or x minus 1 is 0. 2x is -1, so x is -0.5. So I have -0.5 and 1. Now I have to go back there and double check all these. 1, 2, 3, I have 4 different things. Let's try 1 and -1 first, okay, guys? Because that's easy. 1 gives me 2 minus 1 minus 2. So that's 2 minus 1 is 1, minus 2 is negative 1. Absolute value of negative 1 is 1. Yep, that worked. Great. Let's try negative 1. That'll give me 2 plus 1, because I'm minusing a negative 1. So that's 3 minus 2. Absolute, that's 1. Absolute value of 1 is 1. So the 1s are good. Yay. Let's try negative a half. Is it negative? Yeah. So negative a half squared is positive a fourth. So I have 2 times a fourth, so that's a half, minus negative a half, minus 2. Well, that's 1 minus 2. Absolute value of negative 1 is 1. Okay, so that one worked. Shoo. Doing well here. 3 halves. 3 halves squared is 9 halves. No, 3 halves squared is 9 fourths. 2 times 9 fourths is 9 halves. Okay, so I'm going to have 9 halves minus, what was x? 3 halves. Minus 3 halves. So that's 6 halves or 3. So I have 3 minus 2. Yep, that's 1. Oh my goodness, all 4 of these work. Fantastic. Okay. In this type, I'm going to isolate the absolute value. So I'm going to add 1 over there. I could write negative 4x plus 1, but I like to lead off with a positive number if I can. So I added 1 to the other side. So I know that what's in the absolute value either equals this, or what's in the absolute value equals the opposite of this. No difference, even though it's an expression over here. I'm going to add 4x. I'm going to add 4. So x is either 1 or, of course, I'll distribute my negative through. I'm going to add 1 over here, subtract 1 there, subtract 1x. Oh, so x is negative 1. So I have 1 or negative 1. When I put 1 in, way back here to the original, 1 minus 4 is negative 3. Absolute value of negative 3 is 3. And I have to put 1 in for this x as well. So I have 3 minus 1 is 2 equals negative 4. Yeah, no, not in my world. So, sorry, 1. You tried to trick me, but it didn't work. Nope, not today. So, negative 1. Absolute value of negative 1 minus 4 minus 1 equals negative 4 times negative 1. That's negative 5. Absolute value of negative 5 is 5. So I have 5 minus 1. Negative 4 times negative 1 is 4. Is 5 minus 1 4? Yes, sirree. There's your answer. Okay. Same thing here. Absolute value on the left, absolute value on the right. Stand up, sit down, fight, fight, fight. We put what's in the absolute value here. This is so weird, right? 2x minus 3 either equals 2x plus 7 or 2x minus 3 equals the opposite of 2x plus 7. Well, what if I think of it the other way? Maybe, well, 2x plus 7 equals 2x minus 3. That could be true. Or, no, this will do it. We don't have to think of it the other way. I'm sorry. Okay. The other way just gives us these two things again. I have 2x plus 7 equal the opposite. No. That could equal the opposite of 2x minus 3. That will be different, won't it? We have to do 3 different scenarios. Okay, 2x plus 7 either equals 2x minus 3 or 2x plus 7 equals the opposite of 2x minus 3. If I start with this absolute value. If I start with this one, I get 2x minus 3 equals 2x plus 7. So, okay. Oh, well, here I'm subtracting 2x. That just, nothing happens there. I get no solution. Here, though, 2x minus 3 equals negative 2x minus 7. If I add 2x to the other side, 4x, add 3, x is negative 1. The rest quick here, you get